OODAcast, informing your decisions with intelligence, analysis, and insight. Brought to you by the team at OODAloop.com.
In this OODAcast, I get to speak with Chris Wysopal. If you're in the cybersecurity community, you no doubt know Chris. If you're not in the community, let me tell you, he was one of the early advocates for continuous cybersecurity improvement through vulnerability research. He was a member of Loft, then at Stake, has also been deeply engaged with the overall community. He's on the Black Hat Review Board and is frequently seen at our community events and conferences. And he's just a great guy. So if you're not in the community, you're in for a treat. If you are in the community, I promise you're going to learn things about Chris that you wouldn't learn anywhere else. Enjoy. Hello, I'm Bob Gorley, the Chief Technology Officer of OODA LLC, and today on the OODAcast, Chris Wysopal. Chris, thanks for joining me.
Hi, Bob. It's great to join you.
Yeah, thanks for doing this. I really appreciate it. And Chris, I was reflecting back on your career, and I think everybody in the cybersecurity community knows you and knows you're a great person. But not everybody watching this is in the cybersecurity community. And also, there's a lot of folks that know you and like you, but maybe don't have the full story. And I want
Sure.
to dive into all of that. If
Sounds
you're
good.
right. What you're doing today is you are the CTO and chief evangelist of this company you co-founded, Veracode. Uh,
19 years ago. It's a long time.
but I would like to start at the beginning, if you don't mind. And how did you
Sure.
get your start in this field of cybersecurity vulnerability research?
Yeah, sure. So, I think I really early on, like college time, which for me was the late 80s, going on bulletin board systems, I just sort of got a taste for alternative information sources. The kind of the text files that you wouldn't find in the library or they didn't teach you at school. And a lot of these text files were things like, you know, scary stuff like you can make a bomb at home to, if you dial up these numbers with a modem, you get connected to some building maintenance system or something. And I was like, what are all these different things out there that I don't know about? I guess I was just an inherently curious person and just started learning about what people were sharing on these bulletin board systems with text files. And eventually I started to kind of coalesce around, these things that are talking about the security of computer systems is pretty interesting because I was always interested in computers as a kid. Um, Started computing on a Radio Shack TRS-80 in the Radio Shack store because we couldn't afford a computer. So I would do it there. So from a very early age, I was interested in how computers worked and what they could do. And this was sort of I was, interested in sort of the forbidden knowledge about computers. And that really kind of hooked me and just kind of pulled me into this world of sort of the computer underground.
Cool. And then from that, is that about when you started Loft and working with the Loft team?
Yeah, so I guess it was just only maybe a couple years later that I was a young engineer working at Lotus Development, my first job in Boston and living in Boston. And this was pre-public internet, this is like early 90s. And I did run into the Loft guys or the people who would end up founding the Loft, going to 2600 meetings. There was a bulletin board called The Works. We went to that meeting. Think of this, like a bunch of people who online shared text files and messages on a bulletin board, reading and meeting in real life. And I got to know the two of the guys, Count Zero and Brian Oblivion, who founded the Loft in '92, and they invited me to come and help them pay the rent and let me store my computer there. And in the beginning, it was just completely amorphous. It was just like, let's connect up computers, let's share our hardware resources, our software resources, our manuals, share a network. And then it slowly coalesced into this area of vulnerability research, instead of, maybe doing phreaking or other things that were, people were doing at the time, we were like, we want to tear apart software. We want to tear apart hardware too, because we had a physical space. And this mindset of we should learn how these things work from a security vulnerability standpoint. It was kind of the birth of vulnerability research um, in sort of the mid 90s. Like certainly people were reporting vulnerabilities, but I think reporting vulnerabilities and vulnerability research were two different things. Like vulnerability research is like, I know this software probably has problems. I'm going to set it up on the network. I'm going to put a sniffer on it. I'm going to put a debugger on it. I'm going to find problems. That's fundamentally different than a system administrator noticing a configuration issue and reporting it to CERT or reporting it to bug track. So yes, there were vulnerabilities that predated the mid 90s, but I think that's when groups like the Loft started to formalize this idea of let's look for vulnerabilities in a particular piece of software and do that efficiently. And so it was really cool to be doing that at that time.
Yeah, around that time, I was maybe a little bit later, December 1998. A group of us were tasked in the Department of Defense of coming up with the first Cyber Command, Joint
Okay.
Task Force Computer Network Defense. And so a lot of us were, had that hacker mentality no matter what our specialty was. And so we're tracking Loft, everything we could about Loft. And one of the guys who was working with us, Mark Sachs, underscored how important it was to try to work with the community. And then Matt DeVoe is where we first really heard of you
Okay.
guys. He was doing red teaming at the time and underscored the importance of defenders like us understanding this emerging field of vulnerability research. So you've been famous in my network for a long time.
Well, I guess that's a good thing.
Yeah, yeah. It was also very controversial back then because you guys did a lot of
Totally.
stuff that were headline grabbing. Um,
Yeah. That's why we kind of brushed off the term white hat. Like we didn't want people to think we were criminals, and we didn't want people to call us black hats. And they're like, then you're white hats. And we're like, well, not exactly. Like Microsoft doesn't think we're helping them, right? Like a white hat to who, right? And sort of this is where like being a white hat is kind of gray, right? Like especially when vulnerability research was new and there wasn't really coordinated disclosure yet because vendors weren't receptive or listening and there was still full disclosure. We thought this was a gray area. Like this is a ethical, ambiguous area. This isn't neither right nor wrong. To some people think it's right, and some people think it's wrong. What kind of area is that? So that's one of the things we termed the we coined the term gray hat, and we thought that we're going to release security tools that can be used for good or bad like a password cracker, right? You can use it in a pen test yourself. You can use it to audit passwords and tell people, hey, you need a stronger password. But you could also obviously use it to, once you compromise a system, to get lots of account information and reuse that. So password crackers are a great example of a gray area tool. And we thought that that was necessary. Like you couldn't not do the gray area stuff because then you're giving a benefit to the black hats because you're not exploring and using the same techniques.
Yeah, and that brings back memories too, Chris, because I tell you, at the time I was learning everything I could about computers, computer science, and been a bit of a hacker myself for a long time. But I couldn't do all these things that the real elite hackers could. But I could run a tool, I could run a platform, I could run Loftcrack, and next thing you
Sure.
know, I have power and I can learn and I can underscore how important it is to defend and have good defensive systems. So,
Yeah,
oh,
I still have
very
people come
positive.
up to me today when I say like, "Oh yeah, I was part of this hacker group, the Loft," and maybe they haven't heard of the Loft. That they're like, "Did you guys come out with Loft Crack?" And I would say, "Yes, of course we did." And they'd say, "That was great because I was able to show my CEO like how easy it was to crack passwords, and that we had to make sure that people were using stronger passwords, and we needed to care about this stuff." And I'm like, "Wow, this is so great that like people remember it like 20, 25 years later as something that helped them demonstrate that they needed better security. And this was just like the average system administrator.
Yeah. Let me tell you something else I think people remember 25 years later, and that is, Matt DeVoe had written a master's paper that essentially underscored the importance of the hacker community to national security. So this is early thoughts back then.
Mhm, mhm.
And folks like Richard Clark saw that, and we underscored for him the importance of it. He was deep into collaboration and communication. And next thing you know, you guys get an invite to testify in front of Congress.
Yeah.
And I think that's pretty cool and still remembered today.
Yeah, I mean, we got to know Richard Clark in a couple meetings before that Senate testimony happened, and I'm sure he put in a word for it. To this day, I don't know exactly how that happened. I think it was a sort of a conflation of different forces came together at the moment that the Senate Committee of Governmental Affairs was giving the first hearing on computer security. Somehow, someone popped into Senator Thompson's staffer's head that we shouldn't just have the GAO here and someone from SRI think tank, sort of a researcher, academic. We need hackers here. So I don't know how that happened, but we were there at the right time when the government finally had enough sort of pushing at it, maybe from Richard Clark, maybe from Matt's paper, that we can't just listen to the compliance people. We can't just listen to the academics. We need to listen to the I hate to use the word adversary, but the people with adversarial thinking, right? We need to listen to them. And I think that was a huge watershed moment for everyone. And it really kind of legitimized hackers going into become professionals and be legitimate members of the cybersecurity community.
Yeah, I think it did. It really, really did. And it brings back so many memories of things that were just silly at the time. Like I was at JTF-C&D, we get a query from GAO since we're there to do operational defense of DoD, and they wanted to ask us questions. So, like question number one for the Department of Defense was, "Do you have a firewall?" And how do you answer that for, you got 10,000 networks, 6 million computers, and they don't have the ability to ask intelligent questions about what your security posture really is.
No, absolutely. And we all know that a firewall wasn't enough. Yeah, no, it's just it was e- thinking back to the way that people thought about security back then, it was just so basic and so naive. And there was a major change that happened between, say, 98 and even 94, 95. I'm sorry, 98 and 2004, 2005. I think that's when we all kind of woke up to what the level of protection that was going to be needed to defend our networks and data.
And Chris, can I ask, can you walk us through your journey from Loft to Veracode? Because I know there were some other fantastic world-changing companies in there.
Yeah, sure. So while I was at the Loft, and I joined really early on back in '92, just sort of like in the first 6 months that I was getting set up, and was there, and we had some changes in people come and go over the time, but in 90, it was around 98, 97, 98, and I was kind of thinking to myself, I should just get a job in security. Like I was a programmer. I worked at Lotus for a while doing business software, and then I worked as a consultant, sort of freelancing. And I thought, why just do this as a hobby, right? Why just do vulnerability research as a hobby? No, it's fun, intellectually stimulating, but I could do this as my day job. And so my first day job in cybersecurity was at a place called BBN, Bolt, Beranek, and Newman, which was a place that two of the other guys at the Loft worked at, and one of them was Mudge. And Mudge worked in the IT security group there. And for people who don't know BBN, it was a government sort of think tank or technology building company. And one of the most famous things they built was they built the first routers for ARPANET, the precursor for the internet. So people at BBN had been doing internetworking since the 60s. And so it was an amazing place to work. The guy who invented the @ for email, Ray Tomlinson, who invented the email addressing scheme, he worked there. So I got to meet the guy who created the @sign, which is now the most famous delimiter in all of social media and communications, I guess. But it was an amazing place to work. I learned a lot there, and I got to work with really smart people. But then, at the loft, we were still trying to figure out how can we how can we make a non-traditional company. Like I was just going and working IT security at a network company. How could we do something more along the lines of the loft? And so parallel to that, we were all trying to figure out, can we turn the loft into a business? And we were selling some software, things like Loftcracked. We did a couple of penetration tests for businesses. But we realized that at the end of the day, like none of us knew anything about business. We couldn't really raise any money. Like no one wanted to give us any money. We were just too far out there and didn't have enough business experience. So what we ended up doing was we ended up finding a business to join forces with. And this was how At Stake came about. So in the end of 1999, there was a company called At Stake, which was founded by some consultants in the Boston area. They actually got venture capital to build a security consulting company. And they were just looking for talent. And they came across us at the Loft. And essentially, it was kind of a bulk hire. They hired us all, and we became their R&D team. And it really created a completely different kind of security consulting company. If you remember back end of 99, 2000, what security consulting companies looked like, there was two kinds before At Stake. There was a product company like Symantec, which has business consultants, which helped you figure out how to deploy more yellow boxes on your network. And then there was um, your accounting companies, which saw compliance, security compliance, and security regulations as another thing that they could have checkboxes around, right? Which is something accountants are great at, right? Um, so there were these two kinds of companies, both at different ends of the spectrum. One's completely product oriented, and one is completely compliance oriented. And so At Stake was very different. We didn't sell any products. We weren't accountants. We were mostly adversarial, you know, uh, pen tester types, people who could do security assessments. And so we started doing assessments on networks and software and came at it from a perspective as these are all the problems you have. These are how attackers are getting in. Let's make some recommendations for you to help you solve these problems. And a lot of times you didn't even need to buy any more products. You just needed to use them correctly, or just fix configurations in other systems that weren't even security oriented. So this started this whole new way of doing security consulting. And if you were around at that time, there was some other companies that popped up, Guardant and Foundstone, which were much like At Stake. And they all got eventually absorbed. And I think it kind of changed the world of how security consulting worked.
Yeah, even to this day, I really believe there's no way to prove you're secure. You can only prove you're unsecure,
Yep.
meaning you need this ability to continuously test, including testing with people with that adversary mindset.
No, absolutely. So just to continue on the way to Veracode, um, so At Stake was around for about 5 years, and in the end of 2004, I think that the investors realized that even with the dot-com bubble had burst, there was really no way to get VC type returns out of a consulting company, and they decided to sell the company to Symantec. We had built some really cool tools at Stake, and they all went to Symantec. And one of those tools was static binary analysis. We were we were actually going to bring it to market at Stake as a way for developers, people building software, to assess and automate the code review process, right? Instead of having us come in and read lines of code, you could automate that process. That was the promise of static analysis. And Symantec bought At Stake right at the time we were kind of going to market, and they shelved it. They just said, hey, this isn't something that Symantec is in the business. We don't go to market to developers. We don't think it's a security tool. Um, and obviously, application security is a huge part of of cybersecurity. It's a big domain of cybersecurity now. But back in 2004, it really wasn't. It wasn't. It was pretty much brand new. So they shelved it and they laid us off. And so, this was a time when I never thought I would really be an entrepreneur, like a founder. I worked at small companies. I had worked at companies that were startups. I mean, I think I joined at Stake when it was like 10 people. But I never thought of myself as a founder until there was this opportunity. And myself and Dildog from the Loft, Christian Ryu, said we can build a company around what we were building. Was technology was too cool and too valuable to just let Symantec kill it, right? So we raised VC funds. Now, as a first time founder, it's extremely hard to do. I think we met with like 50 different VC firms, and the only way we actually ended up um, getting any money was because Christian had a personal relationship with a guy who was an entrepreneur in residence at this VC firm in Boston. And it was that personal relationship which made the entrepreneur in residence say, hey, to one of the partners, you got to talk to these two guys. These are two of the smartest cybersecurity guys you're ever going to meet, and they're onto something. And it was that personal recommendation which got us funding. Us sitting there telling our story with probably a bad pitch deck never got us anywhere. And it's amazing how it's the right place, right time, knowing one person, they were fraternity brothers at MIT. Obviously going to MIT probably helps too, right? But it's a learning experience. You got to use what you know. You got to need all the connections that you have. And if we didn't have this one connection, Veracode may never have existed because
Yeah. And
everyone kept the door closed to us.
Chris, you fire another neuron for me here, and that is how is a good hacker like a good entrepreneur? And the reason I'm not a good hacker is persistence. The great ones,
Absolutely.
like you and others, have that persistence that just keep hitting it and hitting it and hitting it. And it takes dedication and persistence. And then same for the entrepreneur. You just got to hit it and hit it and hit it.
Yeah, yeah. One of the CEOs at Veracode called it grit. You need to have grit, right? But persistence is probably even a better term for it. Grit makes it sound like you're willing to get your hands dirty, right? Which of course you need to do too. And roll up the sleeves and all these euphemisms, but you got to do what it takes. If you're the only person that can, put the office chairs together, you just do it. But it's really the persistence where I think the feedback loops on hacking, right? You never know. It's sort of like gambling, right? You never know if the next thing you try is going to open the door, right? So you just keep going and you keep going, and you learn that you just have in your mind, you're eventually going to get in, right? You're like, I know there's a weakness somewhere, right? So you're eventually going to get there. I guess for the entrepreneur, I'm eventually going to get that product market fit, right? If I talk to enough people and I keep cranking on it, I'm eventually going to get something that people are going to want. So I think there's a lot of parallels between the two.
Yeah, yeah. All right, so that got us to the start of Veracode. And can you, Veracode has now been around for how long? Is it 19 years?
It's just that 19 years now.
It's great. So in that case, let me ask you this. What is Veracode today?
Well, I'd say that it's changed a bit. I think when we started, it was just pure application security testing, right? It was, we're going to test what the code you've made, static analysis, dynamic analysis. We're gonna test it, and we're gonna tell you where your weaknesses are, and you're gonna fix it before you ship it to your customers, and um, you put it in production. And I think over time, a lot has changed. And the two biggest things I see have changed are we don't write the whole piece of software anymore. It's not 80% our code and 20% the libraries we get from the compiler or the operating system. It's 20% our code and 80% libraries that someone else wrote. Or, and that's if it's just a single process, right? You typically will have multiple processes running in a container, which has all kinds of code that someone else wrote. So supply chain has been something that has been growing and growing and growing and growing over the 19 years to that most of the technology and an application that you build and you control and you own and it's unique to you comes from third parties, right? And so that's been the biggest change. There's been the need to make sure that all that code you're pulling from third parties doesn't have vulnerabilities in it. And that's a lot harder than managing your own code, right? It's a harder problem because, for one thing, it can change out from under you, right? The threat space changes on a daily basis. So some code that you deployed, and that you didn't know there was a vulnerability in, all of a sudden someone discovers a vulnerability in, and people are starting to attack you, right? So the threat space is constantly changing on that third party code. Because the knowledge of attackers on that third party code is much better than yours, and it's constantly changing. The other thing is just the idea that there could be malicious code in there, and this is something that is, I think, been growing more in the last few years. So for 19 years we've had the vulnerabilities in that stuff, but in the last, I would say, 5 years or so, the idea that malicious actors are targeting you through that third party code. It's not just the vulnerabilities that just happen based on normal development coding. They're putting code in there to try to attack you. Whole fake projects, typo squatting, dependency confusion, becoming a developer and playing the long game and being fix bugs for 2 years and then put in the back door. Like, all that stuff is happening now. So the third party stuff is continuously getting more dangerous, and we've had to adapt to that, looking for malicious code in that third party code, not just vulnerabilities. Trying to track malicious actors. So if someone is found to be the one who put in the malicious code in one project, can we see if they're involved in other projects and get ahead of that? So I think supply chain is one of the big ways we've had to change. And that moves us from application security testing to something which is more of a risk management company.
Yeah.
Right. And that's how we think of ourselves now, is really application risk management. And it's not just finding the bugs your developers made. And so we have to take we take a more of a risk management lens on your software now and all of its complexity, right? Because a cloud deployed piece of software is very different than a mobile app or a desktop app, right? Or even the old data center app of multiple tiers, right? It could be made of 100 moving parts, right? Microservices, many, many different containers, all kinds of APIs, both your own within your organization, your cloud provider, SaaS companies you're calling into. It's a very complex environment to have to model now, and how your code is interacting with all of those things. So now the production environment becomes much more important. I used to think we can figure out the security risk in an application before it goes to production, right? By just looking at your code. But now it's very clear to me, and very clear to a lot of people, that how that product is deployed, in what environment, what it's interacting with, and a lot of that can only be seen by inspecting the production environment, really is the total picture. Even though that it's going to tie back and you're going to fix your code, you need this picture of the production environment too. It isn't this perfect chamber that you're deploying your code into. It's a big mess.
Yeah, yeah. And Chris, I want to talk to you about so many aspects of this, if you're open to it. One is, so let me just start with an example. I'm not a developer, but I want to keep learning. So I play with some of these tools, and it's really hard for me to create an application until just this last week. I fire up Grok 3, the latest AI from XAI, and I tell it about an application I want to build, and it walks me through how to build an application. And in a matter of about 2 days, I have built a web app. and it uses the API from Grok and the API from X itself, and it uses MongoDB, and it uses Stripe. It uses a React and Node.js, and it connects with several other services, and it's hosted at a place that I don't know, but but they do this as a business. And I'm not really writing that code. I'm speaking in English to Grok as it is giving me stuff and telling it what I want it to do. And then it says, copy this and put it in your server.js file. And I copy and paste, and I'm not even reading it, but I
Right.
have a working app. Now it helps me to learn a little bit, but it just kind of underscores for me that if a guy like me can use AI to create a working app like this, millions of others are going to be doing that too, and not really understanding what they're pulling together. And for an amateur app like mine, maybe it's no big deal. But if people are doing this for enterprises, this could introduce serious risks just because you're not paying attention to what you're doing.
Yeah, I think this follows the arc of cybersecurity. Whenever you think we're getting ahead of something, like we're finally understanding cloud security models and people are deploying things securely, you get a completely new technology which totally explodes the attack surface, and there's a whole nother set of problems you have to deal with. This is why cybersecurity is definitely lifetime employment if you want to keep working forever. So yeah, I just see this as an explosion of the number of applications or even the size of applications when people can write code with AI code generation and stitch together pieces. We're just going to get more applications. This is just there's no doubt about it because it's easier to build them. So to me, and the thing that I've looked at is, are these applications more or less secure than the ones that were built the old way, where it was a developer writing every line of code, understanding every component they stitched in, learning all of that stuff. And there's been multiple studies on this, academic studies. I spoke about this at the last Black Hat, and the AIs are more or less about the same from a vulnerability density perspective than regular developers. It shouldn't be a shock because that's how they learned how to write code. They learned how to write it on open source code or these big enterprise um, code repositories that people had access to. So it looks like the kind of code that is everyday code. And we all know that there's over 10,000 CVEs each year in open source, right? And those are the only ones anyone cared to find. We know there's millions of open source components out there that these things have been trained on. So I see this as um, a challenge because someone who wrote this application in this new easy way where they were just prompting to do it, it's still not easy to necessarily secure it. And so you need to think about, I need to secure this application just like a normal development team would have to secure the code they built the normal way. But if someone built it with AI, they're just going to try to secure it with AI. And from what I've seen, tools that aren't specifically trained to secure code and secure applications are not that good at securing code. So from my perspective, this increases the number of vulnerabilities in the world.
Yeah.
The vulnerability velocity is going up due to generative AI.
In part because of the number of applications it's creating, right?
Exactly. I mean, even if it was twice as good at writing code, right? Even if it wrote half the vulnerability density, we'd still be having a higher vulnerability creation rate than we have today.
All
It's a
right.
little
Well,
bit scary, right?
I'm doing my part to throw useless apps out there generated by AI. So,
Well, I mean, just think about this from a malicious library perspective. An attacker can look out there and say, what are the top 100 different component open source libraries that are out there? What do they do? What do people want open source libraries to do? Let me have my AI generate 100 libraries that all do all of those different things, and let me put my malicious code in there, or let me just put a lot of vulnerabilities in there. Um, and so that's a way of attacking um, people who might find those libraries and pull them down. But it's also a way of having the next generation of tools trained on bad code and code with backdoors in them. So I'm concerned that anything before, you know, was it 2021 now is sort of like the time when code was out there that wasn't generated by AI. And any as we go further into the future, more and more of the code that AIs are being trained on is created by AIs or created by malicious actors knowing that AIs will be trained on it. Like the code we're learning on now is different than the code we learned on in 2021. And 5 years from now, it'll be different still. So this is one of the sort of the deep problems I get worried about.
Yeah. So there's other uses of AI for the bad guys. The those who want to exploit vulnerabilities are also trying to use AI to create malicious code. Now, from what I've heard, it's still not as good as a good human crafting malware, but in a matter of weeks or months, that could change. What
Yeah,
else?
I mean, I think that they're good. They're fairly good at crafting this stuff. All of them have guardrails on creating malicious code. But I was just looking at someone who was, jailbreaking DeepSeek, and one of the first things two of the classic ones is give me the recipe to make, fentanyl or something like that, or meth, and that's one of the classic things that is obviously there's a guardrail around. But another one that's a guardrail is writing malicious tools. And so they asked it to make a stealthy keylogger that couldn't be detected by antivirus. And it did it. I looked at it. It was actually
Really?
a pretty good job.
Uh,
So I don't know. I think a lot of these open source LLMs are definitely going to help create malicious tools.
all right, that's not good.
Yeah, I
But
know.
let me ask about AI in the hands of defenders like Veracode. Are you guys using AI?
Absolutely. One of the first things we did, and we did this before actually Gen AI hit the scene. We were trying to do this with machine learning, was we want to automate the fixing process. Because we tell developers on this line of code, you have SQL injection or you have a buffer overflow, and here's how you should fix it. Um, that is a roadblock, right? The fact that they have to kind of learn something new and then translate it to their code. What people always want is just sort of like autocorrect for spelling or grammar. Is just give me the thing it should be, right? So for a couple of years, even before ChatGPT came along, we were working on this problem, and we started using GPT-2 actually that came out, and we got it to um, use our training to fix code, where we would give it an example of bad SQL injection and I'm sorry, bad code with SQL injection and the corrected code without the SQL injection. And then we showed it a piece of code that had SQL injection in it that we wanted the fix for. And we said, use these techniques to write me the code diff for this, right? That we can just give the developer a pull request. They can quickly look at it, say, I don't think it breaks anything. I accept this. And so we think one of the only ways to counter the massive proliferation of more code with vulnerabilities is to use AI to fix all those vulnerabilities. Now, we're still finding them our traditional way because we still see that that's really effective. Our traditional static analysis routines. I know some people are using AI to find vulnerabilities. Um, we still think that that's not as good as some of our static analysis techniques we have today. So we're finding it that way, but then we're prompting the AI to, instead of telling the developer, there's a SQL injection bug on this line of code, we just say, you need to fix this line of code to look like this to eliminate the SQL injection. It's a different engagement with the developer. It's like the kind of engagement that you would have if you had a peer that was helping you write better code. They wouldn't just say, your code has a problem here,
Yeah.
and then walk away, right? That's what security tools do. They would say, we need to change the code in this way. And then that developer's learning through that interaction. And that's the way we're targeting it now. So we call it Veracode Fix, and it's pretty cool stuff.
Yeah, it does sound cool. Um, I want to back up because you mentioned Black Hat.
Okay.
I think Black Hat is a wonderful community event, and always then followed by DEF CON, which is also a wonderful community event. And you're active every year in this community. And sometimes I wonder, um, is it why are there so many great cybersecurity practitioners that are so active in the community like this? Is that your personality, or is it your business, or is it a mix of both?
I think it's a mix. It's definitely a mix. I mean, obviously, there's a commercial benefit for me speaking at these conferences or being on the review board for Black Hat. But I generally enjoy doing both of those things. I think it's got to kind of be both. And I love being on the Black Hat Review Board, which I've been on for over 10 years because I just get to see all this great research, right? I get to see all this great research, and I also can have somewhat of the satisfaction of helping some of the best of the research have a stage, right? And picking out, no, this one's really cool. And it's interesting when we're at when we're reviewing a particular track where we have arguments or someone's like, oh yeah, that's been done before, someone's talked about that, and someone else is like, no, this is why it's new, this is why it's cool. So it is an engaging process where you can kind of stand up for some of the research that you think is interesting and also give a thumbs down to research that you think is so derivative. So that's pretty engaging. So I really like being part of that community. And DEF CON, I've spoken at DEF CON a couple times. I mean, I just like going to interact with all the people because it is much more diverse than Black Hat. Just due to the cost, you kind of have to be either corporate sponsored or be a speaker to go there. And DEF CON with its price, which it is getting higher, but it's something that, most people can afford. And you just get a bigger diversity of people. And just I love engaging with all the different villages and the different ways people are thinking about things.
Yeah, yeah. Both of those are great community events, but I tell you, I love the people of DEF CON are also welcoming and friendly and such an enjoyable group. I guess it's a tribute to Jeff Moss and the way he's kept the culture going all these years.
No, absolutely. I mean, like Black Hat does feel like a corporate event, and DEF CON does feel like a community event. And I think they just both have their place, and it's great that you can go to both if you want to.
Yeah, yeah, cool. Let me get back to Veracode and ask about your markets. Who is, which markets are really making use of Veracode?
So, when we started out many years ago, I'm going to say more than 10 years ago, our market was really sort of the regulated companies and the big brands. So it was healthcare, it was finance, it was big brand names that cared about their brand. And it slowly transitioned to basically be every business. Part of it was you have to be taking advantage of software. You have to be able to be building your own software to run your business. So of course we had independent software companies and tech companies, but banks and healthcare can't operate without writing their own software. It's just part of their business, and they look for a competitive edge too. Like they want something that's better than the other. They compete with their software. I remember when Chase Bank came out with deposit your check by taking a picture of it. Like there was a point in time when no one else had that. And it was like, wow, that's cool. I can open a Chase account and I never have to go to the bank or the ATM anymore. Now, 6 months or years later, all the other banks had it. But it just shows that, these features actually they actually compete on them. Um, so those were the customers back then, but I think every company has it's a cliche, every company's become a software company. Software is eating the world. Um, but even government, right? Government is totally dependent on software to run their departments and engage with citizens.
Yeah.
So everyone uses software now. So we have customers from every industry vertical.
Hey. And Chris, you previously talked a lot about the supply chain kind of issues, and now you've just kind of described the market and who needs this and what's happening there. And I wanted to ask, though, if you can look out a few years, how do you think this is all changing, and what will our environment look like 3 to 5 years from now?
Yeah, so I just think that security just keeps getting more and more automated and more embedded into the software creation process. So I feel that someday, like the way you're doing it with the AIs, you're going to be able to mix in building security in, designing security in as part of that process. I think with Veracode coming out with Veracode Fix is just, one way of starting to put that into the process, maybe build it into the IDE or the code repo. I just think that from application security point of view, it's trending towards just becoming part of building software so that every part of building has a security component into it, and you can't build an app without security. So today you're using generative AI to build an app without security because that's how the AIs have learned to build apps. Once we figure out how to build it in at all different layers, then the AIs will learn how to build it that way. So I think I think eventually the AIs will be good at building secure applications, and a citizen developer like yourself will even be able to do that.
Great. And I'll take that as kind of optimistic. But
Yeah.
let me tell you this. I worry because of I'm just I'm an optimist too because I've been in cybersecurity so long. I know you got to be optimistic about this stuff. But the adversaries are getting so many tools at their disposal. Maybe what we can do with Veracode's help is raise defenses on all of our software applications, but then they'll find other ways to surprise us. That's just the way this works, right?
Yeah, I mean that's the whole thing. Like with the latest is it BitBite crypto heist of 1.5 billion? Um, I Trail of Bits had a great blog post on this, and they've been one of the leaders in smart contract, scanning. And up until recently, it's been bugs that have been part of these crypto heists in these different exchanges. When things move from one blockchain to another, there's all these different things going on with smart contracts, and these protocols can have bugs in them. And this is one of the ways that people have drained a lot of crypto. Well, one of the things they talk about in their post is companies have gotten better and better at assessing their stuff. Even the crypto industry is maturing around software security, and their smart contracts are written better, their protocols are better and better red teamed. And this one was a social engineering hack, right? They actually social engineered all the key signers to show different stuff on their screens so they signed off on something that they didn't want to, right? They thought they were just signing off on a regular transaction, and they were signing off on a smart contract change, which allowed the attackers to drain money out of the wallet. And so I guess we can look at it as if someone gets to doing social engineering is the only way in, you've done a great job on your technical stuff, but
Yeah.
you
Yeah.
still have a problem, right? And
Yeah.
and social engineering will always be sort of that last mile. And we need to build defenses around around the different ways people are social engineering these days.
Yeah, that's a very good point. Very good point. And I think we need to do our part, secure the applications, secure as much of the enterprise as possible. But that social engineering is always going to be with us.
Totally.
Yeah. Well, Chris, I really appreciate the time today. And I wanted to wrap up with a concluding question of, all right, so what is your advice to the enterprise leader today on what they can do to reduce their risk?
Yeah, so I think I'm going to go along that social engineering front. I think that one of the things that you have to get a handle on is security awareness in your organization. And part of it is like getting people to understand why they have to go through the pain of two-factor and not complain about these things, or some of the controls you put in place, because it isn't all about teaching everyone to do the right thing all the time. It's getting them to accept the security and not try to bypass it, not try to move documents around, the way that you've put things in place, because they understand why they're there, and they understand why bypassing those systems, because you can always bypass systems, right? It's extremely hard to lock everything down and also have a productive environment, right? There's a balance there, but you want people to follow the way that you have set up things, so they're not trying to bypass and email attachments to themselves and things like that to bypass controls. So I think security awareness is great for not clicking on things or noticing something is off and sending it to your internal suspicious email address or something like that. So I think that's good. That's never going to be 100% because there's always going to be a new social engineering attack that it's going to trick people. But getting people to understand why controls are in place and why they need to not go around them, even if they're the CEO, and get even the leadership of the company not to think that they're special because they're under attack. And then I think awareness is the way you do that, and shows the value also of all those systems you're putting in place.
Yeah. Thanks, Chris. Thanks for that. And thanks for all this today. And when it comes to awareness, just to get back to our earlier comment, another good reason to have solid red teaming efforts. Let's be aware of how hard it is to get in, and after you're in, how long it takes to be detected. And I think it's a great awareness builder.
Absolutely.
Hey, thanks for everything, Chris. Really appreciate this.
Thanks, Bob.
Thanks for listening to this OODA Loop production. For the latest analysis on cybersecurity, technology, and global risks, please visit www.oodaloop.com.